We are in the home stretch, problem number 17 on page 463. Oh, I like these with these strange operations. Let the operation up arrow be defined as A up arrow B is equal to A plus B over A minus B for all numbers in A and B where A does not equal B. A does not equal B. And why did they have to say that? Well, because otherwise our denominator would be 0. So we know that 1 up 2 is equal to 2 up x. What is x? X equals, So let's set up the equation. So what is 1 up arrow 2? So that is, we just use this, that's 1 plus 2 over 1 minus 2. So it's 1 plus 2 over 1 minus 2. I just use this formula. 1 up, 1 is A, 2 is B, right? And that equals, what's 2 up arrow x? That's 2 plus x. 2 plus x over 2 minus x. 2 minus x. So 1 plus 2 is 3. 1 minus 2 is negative 1, right? So it's negative 1 is equal to 2 plus x over 2 minus x. And of course, this is just equal to negative 3, right? And now we can multiply both sides of this equation by 2 minus x. Because we know that x can't be equal to 2 because it says a can't equal to b. So we know we're not multiplying both sides of this equation by 0. 2 minus x, right? That's all I'm doing. I'm just multiplying both sides by 2 minus x. And then I get, on the left-hand side, I get negative 3 minus 3 times 2 minus x, right? And on the right-hand side, the 2 minus x's cancel out, and I get 2 plus x. And then I distribute the 3. Minus 6 plus 3x is equal to 2 plus x. And let's see, where do I want my x's? Let's add 6 to both sides. 3x is equal to 8 plus x. Subtract x from both sides. 2x is equal to 8. X is equal to 4. Choice A. Okay, problem number 18. I'm going to switch colors too because this color is not appealing to me. Let's see, green. 18. Looks like this involves money, so green is good. 18. During a sale, a customer can buy one shirt for X dollars. So 1 for X. One shirt for X. Each additional shirt costs Z dollars less than the first shirt. Each additional shirt the customer buys costs Z dollars less than the first. So additional Z less than first. Than the first shirt. For example, the cost of the second shirt is X minus Z. Alright, fair enough. Which of the following represents the customer's cost in dollars for N shirts bought during the sale? So N shirts. N shirts. So the first shirt is going to cost X, right? The first shirt's going to cost X. And then how many shirts are left? Well, there's N minus 1 shirts that aren't the first shirt, right? N minus 1 shirts are they buy one shirt at X, and then they're going to buy N minus 1 at the other price. And then the other price is X minus Z, right? Because all the other, and they actually, they're not ambiguous, but it's not like the third shirt costs Z less than the second, and then the fourth shirt costs Z less than the third. They all cost Z less than the first, right? So every other shirt costs X minus Z. So we have N minus 1 other shirts, right? We had the first one costs X, then we have N minus 1 shirts that cost X minus Z dollars. And did they write it like that? Yes, that is choice A. I thought maybe they might have multiplied it out and we'd have to, look for something similar, but they gave it just the way it is. All right. Next problem. Problem number 19. Okay, 19. So they drew, I don't need to draw it neatly. I could draw this thing freehand. Okay, so this is P, 30 degrees, Q, and R. In the figure above, QR is the arc of a circle with center P. If the length of QR is 6 pi, so this is 6 pi. 6 pi. What is the area of sector P? So this length is 6 pi, so they want to know what this area is. Well, the important realization is that this is part of a larger circle. So if I were to draw the entire circle like that, and then I were to draw, let me do it in a different color. This is part of a larger circle, where this, it's P, Q, R, and 30 degrees. And this 30 degrees is important because it tells us what fraction of the larger circle this is. Well, how many degrees are there in a total circle? Well, there's 360, right? If we were to go all the way around, there's 360. So the fraction that this is of the full circle is 30 degrees over 360. And this is 1/12. 1/12 of the entire, I haven't drawn it to scale. The way I drew it, it looks more like 60 degrees. But if you should be able to draw 12 pi's of 30 degrees here, right? Hope I'm not confusing you, because there's 360 degrees in the circle. So if this slice is 1/12 of the whole circle, then this arc length, this 6 pi right here, 6 pi, is going to be 1/12 of the entire circumference. So what's the circumference? The circumference is going to be 12 times this. So the circumference is 12 times 6 pi, which equals, 72 pi. If the circumference is 72 pi, what is the radius? Well, what's the formula? Circumference is equal to 2 pi r. So we could say that also is equal to 72 pi. So you could, divide pi by, divide both sides by pi, and then divide both sides by 2. You have the radius is equal to 36. So this radius right here, this radius, let me do a different color. This radius is equal to 36, right? All I did is I figured out this arc length is 1/12 of the entire circumference. And so the entire circumference is 72 pi. And then I used that to figure out that the radius must be 36. Now we want to know the area of just this piece. So we could just figure out the area of the whole thing and then divide by 12, because this is 1/12 the area of the circle as well. So what's the area? Area is equal to pi r squared. That equals pi times 36 squared. I'm going to write 36 times 36. I don't want to multiply big numbers. And then that's the area of the whole thing, is pi times 36 times 36. So the area of just this fraction will be the area of the whole thing divided by 12. Divided by 12. And the reason why I didn't multiply it out is because I can actually cancel. I could say, well, this is 3, this is 1. So it's pi times 3 times 36. And what's 3 times 36? 90 plus 18 is 108. So it equals 108 pi. Which is choice A. Let's see if I could squeeze in the last problem. Probably not. Actually, I will save the last problem for a video of its own, because I only have a minute left. See you soon.